Today, we will be talking about removing one of the biggest bottlenecks in software testing, which is test data. And I'm actually really excited to present this material to you because I think that test data is one of the most significant challenges we do face today. So test data, as I indicated before, is one of the key enablers and blockers to our business. And key is a very interesting word when it comes to test data because I think there's some pretty neat analogies between keys and, more importantly, locks and test data. Here's a question you might ask yourself. How would we test a lock, a standard lock that would go onto a house? Short answer is we test it like we would test any of our applications. We would try a series of inputs. In this case, they would be keys. We would expect that we should be able to stick the key into the lock, and if we have the right key, it should turn. And no other key should allow us to unlock that lock. Now, how many keys or combinations do we think there are for a standard house lock? Well, I went ahead and did the math, and it turns out that your standard lock, it has a 5-pin system, and each one of those pins can rest at a depth of 9 different depths. And so if you do the math there, it means that you have 59,049 possible combinations for a key that could go into a lock. Just for a frame of reference there, Disneyland, Parasoft's here down in Monrovia, California, and just around the corner, we've got good old Disneyland. Disneyland receives approximately 44,000 people a day. So that means that if everybody at Disneyland had a unique key, we still wouldn't have all of the possible combinations. And this is very similar to our software testing. And we need to be able to test different components of it, and to be able to do it, we have to have the right set of inputs. And even with something as simple as this, it can be a pretty large combination of inputs. But it turns out that it's not as simple as just a single lock. Well, it turns out that there's actually 7 different manufacturers of keys, at least here in the US. Major manufacturers are August, Baldwin, Kwikset, Masterlock, Medco, Schlage, and Yale. And each one of these key manufacturers has a slightly different way of setting their pin depths. And so if you do the math there, it means that there's 413,343 different combinations of keys. The current population of Omaha, Nebraska is sitting at 411,000. So even if you grabbed everybody in the state of Omaha and they all had their own unique key, you wouldn't not have all the possible combinations for the locks that are out there. Now, this really equates to how we do the different types of testing in our application, because there's different ways that we interface with it. We'll get into them in a little bit, but it starts to call out the problem, right? I have to have the right data. I have to have the right key in order to unlock this interface or to unlock this testing. So the easy solution might be, well, let's go ahead and just get all of the keys that are out there. But here's the problem. Data is dangerous. I don't know if any of you guys are Harry Potter fans. I am. This is one of the scenes in the Sorcerer's Stone there where he was trying to get one special key to unlock the next piece of the puzzle here. But you can't just have all those keys hanging around. They're dangerous. And initiatives like GDPR and PII not only make it dangerous from a brand erosion perspective if we were to ever have a leakage, but there turns out to be fines and compliance issues associated with it. So we need all the data, and we need it to be the right data, but we can't just get all the data. And so that's really the problem. And as this manifests in organizations, they typically go through different phases of testing, and each one of those different phases requires a different type of data. So for example, in the early stage of ideation and creation, when we're experimenting with a new idea, we may need to try different combinations of data to see how they manifest with our experimentation. We then go on to say, hey, let's actually start writing some code for this. And so as development starts building their tests, they're going to need the specific data to test their classes, their methods, their objects. And it needs to be pertinent to what they're doing and to have the right types of values so they can do their assertions. As we move into functional testing, not only do we have to have the right data for particular objects, but we need to have also nominal and non-nominal testing that's data that still makes sense, positive, negative, maybe data that's has unexpected characters, things like that. And then when we start bringing different components together, we need to see the impact of different types of data in different components as they interact with our APIs and our interfaces to see if the introduction of corrupt or unexpected data causes our applications to collapse or manifest unexpected behavior. The list keeps going. When we think about regression testing, not only do we have to have all of the data, both positive and negative, expected and unexpected, but we also have to have today's data and yesterday's data and the day before that, so that we can validate that the way that people are using the applications continues to work as we add new functionality into that. And when we get into performance testing, we need all of those characteristics, but we need an abundance of this data because of things like data caching or data burning to allow us to do shift-left performance testing. So all of these different activities require data and to have the right data. But they each have their own individual tweaks on it. And so, data is a problem. And we see as organizations start trying to approach this problem, there's an interesting curve. As their test maturity starts increasing, things like adding in different types of testing, unit testing, API testing, potentially earlier stage scenario testing, data requirements start increasing because the complexity of the scenarios that they're testing is also increasing. And so as the organization gets better about this and starts adding in newer and more advanced types of testing, their data complexity starts to increase more and more. They're doing a good thing, but the data monster is looming in the background. It's usually at this point that they decide, hey, we need to do something about that. And maturity doesn't stop. We're still going to keep adding new and more experimental types of testing into our applications. And by this time, the data complexity required to meet our requirements is so complicated that when we start bringing in test data management, it has one of those chicken and the egg effects. We need the test data, but how do we get it? How do we get it to satisfy our needs? And the cost of the complexity of data, the costs are real. In surveys, we see that up to 60% of application development time is solely devoted to data-related tasks, getting the data, waiting for ETL jobs, trying to figure out what needs to be in a particular data set, and letting the test data management team know that. Well, what ends up happening is that we get a lot of these requirements set, but then we have to wait for that team to give us the data. And as a result, many projects overrun simply waiting for the data. In fact, 20% of the entire SDLC is devoted exclusively to just waiting for that data. But we're testers, right? And we got to get the job done. So what do? We soldier forward with the data that we have, even though it's not everything that we need. And so what ends up happening is we don't get full test coverage, which ultimately ends up leading into defects in production. Now, there are solutions for test data management. Here are the three traditional approaches to test data management: cloning or copying production databases, subsetting or sampling those production databases so we get just the data that we need, and then finally, generating or synthesizing the data that we need. And so let's talk a little bit about each one of these. So starting with cloning or copying a production database, the pro of this is that it's relatively simple to implement. There's a lot of technologies out there to do it. We can simply say, well, this database has all the data that we need with all the different combinations. Let's just pull that in and start using it. But there's actually quite a few cons associated with this. A database is a database, and if you're pulling from one database to another database, there's licensing costs associated with that, infrastructure. There's time that's taken to refresh the data and get into that proper window, and it's not scalable across multiple data sources or applications. And I think the most important piece or risk that we have with pure cloning is data privacy and the risk that our data may be exposed from production into our test databases. So we have to mask, have to go through the process of masking. So as an alternative to that, we can think about subsetting the production database. And subsetting is the idea of simply pulling out just the data that we need for our different types of test cases. It limits our exposure a little bit. Same thing, if we know what the right rules are, we can pull that in, and it's less expensive when compared to purely generating or synthesizing the test data. But we still have some cons associated with that. How do we know what the right test data to pull out of the production database is? There's typically a lot of rules. There's a lot of referential integrity that needs to be maintained, and understanding how to get my data to me in my test environment requires a fair bit of expertise. And so what ends up happening is we typically only see 20 to 30% of functional coverage that exists in that production database, and we still need to have a database. And oh yeah, you still have to mask that data because it's coming from the production database. So many organizations are looking to generate or synthesize data. There's some good pros to this one. It doesn't contain real data. So your masking problem becomes quite diminished. You're synthesizing that data. And actually, you might be able to get a much higher percent of functional coverage because you can generate different types of scenarios that might not have existed in the production database, which is great. But there are some cons to that too. Synthesizing data is quite complicated. And understanding exactly what data needs to be generated and for what use cases and where does it go and how do the different relationships exist. And I still have to push it into a database. And so these are the three options that are ahead of us. And so each one, as I said, has a pros and cons associated with it. But these are the approaches that we're looking down. But the purpose of today's webinar is to talk about what the common challenge with this is and why it ends up being a bottleneck. And I'm going to suggest another approach that we can take to test data management. So let's talk about the underlying problem. The underlying problem really comes with the reliance on a shared database. Now, typically, when we think of the test data management approach, we have different application testers and developers that are building their applications and testing their applications against a common database in their test environments. Now, when it comes time to copying, subsetting, or generating that data, typically what we see is that there's an activity that takes place on either a production database or this tested database, where they'll go and they'll do a pull or a subset. And the test data management team then has processing time and to build that right data. As I said, there's some time associated with that. We then have to wait for those ETL or refresh jobs to then push the data back into the database. And at this point, it's like, okay, we're okay. We can now test against this, our applications because we have the data that we need in our database. But this is what ends up happening. As different application testers or developers start working with their applications, they may have stateful transactions that alter the data in the database. And so as our different test cases are firing off, if we're not managing it with laser-like precision, we start stepping all over each other. We've seen many organizations that have approached this with traditional test data management solutions and said, hey, it's great up front, we get the data that we need, but managing it can be very difficult, especially understanding what happens when we're conflicting with each other or data is changing. And the real problems, the real defects that we're trying to find are just getting lost in the noise of the test data. So I think there's an option 4, and that option 4 is service virtualization. And so for those who are unfamiliar, service virtualization allows you to simulate backend components that are unstable, unavailable, or do not have the proper testing or data for your requirements. And with service virtualization, we can simulate those backend components and then use those as a vehicle to give us our data. So a little bit on the architecture. When a typical application is being tested, it has a series of interfaces on the front end, some components in the middle, and then some back-end systems. And so when a tester goes to approach this problem, they have to think about the different interfaces and how we're going to test those. Now we have solutions that are out there, open source, free, maybe even something like Parasoft, where we can test with Appium for mobile, Selenium for web. We're seeing some Postman for API. But the challenge is that a lot of these require development expertise to test, as well as each one will have a different result that has to be aggregated into some meaningful way. This is where our test automation allows us to create omni-channel tests, especially with Parasoft SOA test, where we can cover all the way from mobile to mainframe, focusing on our APIs and our database tests and stringing those together into a meaningful omni-channel test experience that really validates the user's requirement. Now, as many organizations reach this stage of omni or multi-channel testing, the problem really shifts into those back-end systems. Because we have components, as I said, that could be unavailable, unstable, not having the right type of behavior. And a lot of these really are test data challenges. And so service virtualization allows us to not only simulate and stabilize those backend components to make them available for our testing, But by combining that with test data, we can provide realistic scenarios into those back-end systems that we understand and allows them to behave the way that we want for our testing initiatives. And because each tester may have a different testing initiative or different requirement, we can package those different applications up into a scenario where that can be then delivered to an individual tester right there on their desktop so that they can test in a local way against their application with virtualized dependencies, as well as being integrated into the overall CI/CD pipeline, where this containerized environment, which has test cases, virtual services, test data, and all of the different configurations that we require, can be deployed as a function of code check-in and orchestrated with container services such as Docker and Kubernetes, potentially on-premise or in the cloud, to allow us to create this anytime, anywhere testing that has all of the right behavior that we need. And the end goal here is by being able to control this more holistically, we'll be able to get better test results, because that's the real goal at the end of the day. So how do we do this? How do we virtualize? Well, virtualization is typically a 5-step process. The idea is that you have your application that your developers are currently working on that you're trying to test, and you have your testing tools, SOA test, potentially Postman, load test for performance testing, and you will have that application with back-end systems such as a database or some other REST or SOAP services, maybe some microservices with Kafka or Rabbit, mainframe, or some kind of back-end dependency. Virtualization allows us to define monitors or proxies that intercept the communication between our application and the back-end systems. And as we invoke our test automation against our application, you can see the transactions that go between the application and those back-end systems. That information, transaction and data, can be delivered to our service virtualization engine, which will allow us to create simulated virtual services and their associated test data. Those virtual services can then be deployed into a centralized virtual service repository that will allow us to consume them anytime, anywhere. Now, this is where most service virtualization solutions stop, but there's a key component here that's required, and that is the orchestration of the virtual services. We all have some kind of CI management process, Jenkins, Bamboo, Azure DevOps, TeamCity, any of these different platforms. And through Parasoft, we can coordinate the activity of these proxies that were first used to record the traffic to now redirect that traffic to our virtual services so that individual testers, developers, performance engineers can get their virtual service with the test data that they need. And they can then just execute their test automation and it will have stability. So our approach to test data management is in the combination of service virtualization and traditional test data management, where we originally have a shared reliance on that centralized database. We can remove that shared reliance by swapping out virtual services and use our test data management engine to allow individual users to provision, generate, subset, mask, and create exactly the test data that they need for their individual needs. And so I'd like to walk you through that today and give you a demonstration on how this all works. So the pros here are that it doesn't require the underlying database infrastructure, which is key. By using service virtualization, you're simulating the vehicle by which your data is being delivered. It also allows you to carve off your own little fence in the test environment to do exactly what you want to do. Corner cases, positive, negative, nominal, non-nominal, performance, different types of data. Now, these are all the pros to it. I'll tell you though, there is a con. While you can virtualize all different types of behavior, it's not a real database. So when it comes to changing the state, it is 100% achievable, but this is where you need to make the differentiation between the different types of testing that you're doing. And when you're validating your application, you need to take that into account. So a holistic approach to solving the problem of test data management is in the combination of service virtualization with a test data management solution of your choice. We're big fans of DATProf over there. If you're not familiar, go ahead and check out their website. But the idea is that service virtualization allows you to simulate all of those application dependencies where you don't have access to the data, or the data is unavailable, the data is unsafe, or you want to be able to remove yourself from being constrained with other testers or other developers. And then you use the rest of your test data management when you're actually testing the database functions, and you want to make sure that the database behaves the way that you expect. By combining those two together, it allows you to model the relationship of the data, build the data that you need in your virtual services, and test away. So with Parasoft Service Virtualization's Test Data Assistant, there's a 4-step data lifecycle that typically follows these 4 activities: management, masking, model and generation, and then subsetting. And so I'm going to walk through each one of these and give you a demonstration. So let's start with capturing and managing the test data. So where does the test data come from? Well, it comes from interactions with our dependent components, whether it's a RESTful service, a microservice, or a database, which is what I'm going to be using today. And we can either extract it directly out of the database, or, as I'm going to show you today, capture it live over the wire. We can then mask that data, subset it, make it appropriate for our virtual service, and then use that. So let me go ahead and open up Parasoft here, and I want to walk you through that. So what we're looking at here is Parasoft's continuous testing platform. It's a thin client interface that allows testers, developers, ops engineers to come together to plan, coordinate, execute test activities. It holds a library of test cases as well as virtual services and test data, and allows us to control our environments and provision them for test execution. So I'm going to be working with an application today called Parabank. It has a series of middle services, some back-end services, including a database, and a front-end UI and mobile interface. I've diagrammed that out here in my environment manager, and let me actually show you the demo application. So here's Parabank, and what it allows me to do is to take a look at the different types of behavior that I have. Hold on one second, let me log in here. Make sure it's secure. And as a user, I could open new accounts, transfer funds, request loans, so on and so forth. And so what I want to do today is I want to test this account's overview behavior, because I've added some logic in here to validate positive and negative account balances, and I want to make sure that that works appropriately. The problem here is that my data doesn't actually have any negative account balances. Contrary to my own personal bank account, this one tends to not go negative. I can solve this problem by capturing some data and then slightly modifying that. So let's go ahead and do that part first. So back here in Environment Manager, I can do just that. I can manage the environment. I have a series of components. That front-end UI is connected to a series of services that call out to an IoT device, a live database, and a third-party service. I'm going to go ahead and choose a different configuration where everything is put into a live configuration. And then I'm going to go ahead and say, let's go ahead and record transactions against that database. I'll go ahead and provision this. This then goes down and tells that database to record. I'm going to look under the hood real quick and just take a look at what that means to ensure that my little controller there is in record mode. And then we'll use this console to see the traffic going over the wire. And then to record that traffic, I simply use my application. So let me do that. I'm going to go ahead and log out. I'll log back in here. I'll go ahead and take a look at my accounts overview, maybe drill into an account. Okay, that's probably enough. I'll go back here to my little logger and look at all that wonderful data. So here I'm seeing all of the different queries that just got fired off, what their result sets are, and I see that Parasoft is capturing all of that information. Okay, now what I want to do is I want to use that information to create a virtual service. And so to do that, I'm going to go ahead and drop here into my virtual services or virtual assets project and go ahead and create a new virtual service. I'm going to call this Parabank database accounts. And then I will choose recorded database queries. And it will then look down on all of the available machines that I have and choose all of the available databases that I've recorded and give me the ability to go ahead and say, all right, let's go ahead and create that database. I'm going to stuff this into a temporary data storage here called data repository. Just make sure it is live. Yep. And I'm just going to do this for now just to show you the data, but I'm going to delete it later. So I'll go ahead and say finish. It's going to go through, make all of the necessary things for me, and deploy a virtual service. So here I have my virtual service, and my virtual service really is just a virtual service connected to some data. So this is actually all we have to do for this virtual service. So what I'm going to do now is I'm going to go ahead and look at the data. It is in this thing called data repository over here, and the data is called accounts. So most of our activities take place right here inside of our thin client. It makes it much easier to allow broad access to the solution. So I'm going to go ahead and jump from here into my test data assistant. So test data assistant allows me to look at all of the different data sources that I have available to me in my testing infrastructure. And so here's the new one that I just created right here. I think I called it, database to delete. And that database to delete contains all of the different queries that I made. And those queries also have associated result sets with them. So I actually have one that I created ahead of time, which I'm going to go ahead and look at here, which is called Parabank Database. And so I can come into any of these different data sets. For example, this one where I'm looking at type ID balance. And this is actually the one that we're looking at inside of the UI. So what I'm going to do is I'm going to use this virtual data. And I can do that by simply going back into my dashboard, going back to my environment, and saying, let's go ahead and use the virtual data. I'll go ahead and provision that. This should now be connected to my virtual database as soon as it finishes there. Oh, it's actually going to run some tests. That's OK. As soon as it finishes here, I'm going to go ahead and jump back to my application, and let's just see if it's done. Do a little accounts overview. OK. It looks like it's the same data, but what I can do in my test data assistant now is have total control over that data. So for example, if I wanted to take this account balance here, which is currently $100, and say make it negative, it's as easy as modifying the result set, saving, and when I come back into my application, I now have total control of the data. And this is great, because now as a tester, it's very easy for me to add new rows of data, to modify, to change the order, to change anything that I want in that set. And if I want to do something crazy, like test the bounds of my data, I don't know, what kind of data I could get in that production database, but I know here I can do anything that I want. And so really, this is the first stage of our data management. And that is that we've gone through and we've understood what the different use cases are against our database. We've recorded them and then created a data set from that. So now that I've recorded that data, a very interesting thing has happened. I have the data. And here I'm just showing a slightly different type of data. This is a data that I would get from a RESTful service. It's exactly the same thing. Whether I've recorded from a database or a RESTful service, anything that goes into my data storage can now be abstracted automatically into a model. And that model allows me to understand the relationships of the different types of data that I have. And this is the key to moving on to masking, generation, and subsetting. This is usually an arduous process, but because our underlying heuristics can process the data object, we can automatically build the model. And so that takes us into masking. So now I've recorded some data. I have introduced some risk. I don't know if that data has come from a production database. It's not totally clear to me in this demo. So what I need to do is I need to mask this data and ensure that it's safe for further testing. So let me demonstrate how you would do that. So here, I have been working with my result sets, kind of working directly with the SQL queries. I can go to my models section here, and it will take me to the model of this database. And a model is a representation of how all of the different queries connect to result sets, their relationships, so on and so forth. So let's look at the one that's interesting to me, and that's my account list. So the account list is actually the object that we've been looking at this whole time. When I recorded it, it was $100. I know that I've now altered that slightly. But one of the things that you'll see here is that through recording, I've been able to automatically infer the constraints. And the constraints tell me, well, is it a number? Is it a string? Is it a Boolean? Is it a date? Once I understand that information, it becomes quite easy for me to start manipulating that data. So I'm going to play with this in a second, but there is something that's a little risky in my account. And that is when I look at my account information, one of the things that's actually sent under the hood here is the social security number. Now, I can't have social security numbers in my data set. That's unsafe. So I'm going to go ahead and look in here to see if there are any types of behavior or data that follows a certain pattern. And I see here that in my customer object, which is down here, I have a social security number. That social security number, it's identified as a string, and it looks like this. I want to mask that. I don't want this value to show up anymore. And so to mask, it's quite simple. I simply go to the object and say, let's go ahead and mask. And with masking, I can mask either with a formula from seed, random, ranged. I'm just going to do a random masking. I'd like it to follow the same pattern, and so I get some help here. And it says pound symbol is numbers, so I'm going to go ahead and use that. 1 pound, 2, and then 4. Now when I save that, it's now added a new mask/generation piece of information here that says if I ever mask, it's going to use this pattern. But something else that is interesting to me is if I look for the other social security number areas, there's another one that actually exists in a different result set. So let's go ahead and jump up there. Okay, so it looks like kind of the same information here. This social security number probably exists with the same customer. And so when I mask it, I want to make sure that I have referential integrity between this social security number and that social security number. And this is quite simple. I can simply come down and say, let's go ahead and set a data constraint and say that this social security number is actually a reference to that other social security number. I'm going to say save. I got a cool little line that shoots across my model here. Helps me to understand that there's a relationship between these two social security numbers. And going forward, any operation that I do on this will preserve that integrity. All right, what's the social security number? 622-11999. Let's go ahead and mask this data. I'm going to create a new data source here called Parabank Data Mask. And it's going to get rid of that dangerous value for me. I'll go ahead and jump into this masked. I want to look at the social security number again. I'll go and find it right here. I can then go back up to its parent object and follow it to the data. So what was it before? Something with some 9s in it, right? 699, something like that. Well, here it is now, 612912726. That's safe for me to use. I feel comfortable. And going forward, I can mask this data and then ensure that any further operations that I do are working on safe test data. I can also audit that this has happened so that I have traceability. All right, so that takes us to our third operation, and that is being able to expand the data coverage. The really cool part here is that since I've already been able to abstract a model from this data, I can use that model and the constraints that I discovered to do all sorts of crazy things with my data. And this is important if I have data that becomes obsolete over time. Timestamps change, accounts close, objects change their shape or their properties, and it's really valuable for repurposing that data. I can extend what I currently have, or I can use seeds or other data sources to extend that data. So let's go ahead and take a look at how you would do that. So I'm going to go back here into my data source here. And I'm going to go ahead and look at the model again. Now, what I really want, what I said, was I wanted to be able to test negative account balances and to see what would happen there. But I need an abundance of data because I am going to be doing some performance testing against that. So what I'm going to do is I'm going to jump in here and I'm going to say, let's make 100 accounts. How do I do that? Well, let's go ahead and start with that object that I know I need to alter, this one. So I have my constraints, and if I'm going to generate 100 accounts, I'd like them to all have different values and properties to them. And so let's go ahead and start with their balance. So I'm going to go ahead and go into that same UI, So it becomes pretty easy to remember how to do these things. And I'm going to say I want my accounts to have random balances. I'm going to go ahead and say that I want them to be somewhere between negative $5,000 and positive $5,000. Nice range of values there. I don't really care about the last two digits here, so I'll go ahead and save that. All right, so that's one strategy. The next thing is my IDs. Every one of my accounts should have a unique ID. Now, I could do that randomly, but I'd like them to be in sequential order. So I'm going to go ahead and choose my range here. And a range allows me to create a range of dates, a range of numbers. In this case, we'll have my new account start at 20,000. And I only need 100, but it doesn't really matter. I'll put 22,000. It'll stop whenever it needs to. And then for type basically just means whether it's a checking account or a savings account. So in that, I'm going to go ahead and do the same thing, mask. I'll just do a random account type between 0 and 1, checking and savings. This is also possible with a Boolean. Okay, so from this, I'll be able to go ahead and generate my accounts. But I'd like to do more. I'd like to change the way that customer information looks. So let me go back to that object that had that social security number in it. That's this guy over here. So I want to generate some random information for this customer. One thing that might be interesting is to give them a random first name. Now, I could do a random string here, but that's not a real name. It just would be a series of numbers and letters. Well, I'm a big Marvel fan. And so I think instead what I'd like to do is to give each one of these people, the new accounts that I create, a Marvel character as a name, because it's a real name. I can pull data from seeds. A seed, as I said, is a different data source or a different type of data that you have anywhere in your data library. Now, we supply some values here, but I actually ahead of time recorded some information off of the Marvel API, which is a really fun API for any of you techie guys on the call. A lot of operations in it. I virtualized it, and so I recorded some data against that. And one of the things that they have in this giant data source is a character name. So what I'm going to do is I'm going to say, whoever the new account that's randomly generated will have a random Marvel name for the first name, and why not, we'll give them a different name for the last name. So we'll just do the same thing, mask and generate, random, from seed, and I'm going to look to my Marvel and pull in my name. Okay, one last thing, password. I'm going to random password here. Now, the interesting thing about passwords in my organization is a password is actually a combination of two different values, a first name and the zip code that the person lives. So to accomplish that, I can use a formula. And a formula is exactly what you would think it is. It allows you to do things like date shift, substring, uppercase, lowercase, really play with the data. So in this case, what I'll need is to concatenate. So I'll go ahead and insert that guy, a couple of values together. I'll do this little symbol here, and I'll say it's going to be the first name of the person plus or added to the zip code of the person. Oh, let's try that again. And I'll do a little preview here, see what I get. King Bedlam, 90210. So, you know, this is a pretty simple formula. You can get pretty crazy with this, and this is where you start getting some real value in personalizing that data. So I'm going to go ahead and save that. And so, okay, I've done a series of different things to my data source, formulas, random generation, a numeric or ranged generation. I've also referenced some different objects together. Now, the last thing that I need to do is I need to tell it what to generate. So in this case, I want to generate this accounts list. This accounts list is an object, and I want 100 of these. Right now, it's currently saying that as far as it knows, only 2 ever exist. The minimum and maximum are only ever 2. Well, I'm going to change that. I'm going to tell it, well, actually, the minimum and maximum that you should create are 100. And you can do this randomly if you want with different minimum and maximums. But if you want a specific number, you can do it this way. Just so you know, everything that I'm showing you today is available as a easy to look at tutorial, which I will show you towards the end of this if you're interested in playing with this yourself. Okay, so I'm generating 100 accounts. They have some random values to them, some from seed, some from formula. Let's go ahead and do this. So I'm going to go ahead and tell it to generate data. Now, the cool part here is that it's going to understand what the actual number of records that I have from the original recording are. And if I want to preserve the same type of behavior but slightly alter it based on my rules, I can simply do that. And if I want to include that original data, I have the ability to do this here. And everything that I'm doing here is available as the REST API. So if I want to do this as a setup prior to my test execution, I can do this in a fully automated way once I've set all the rules. And this is a very powerful way to get just the data that you want and then destroy it when you're done. All right, well, with no further ado, let's go ahead and generate this data. Okay, so it's gone through and it said it successfully generated the data. Here's the data right here. I'm gonna let that data model load. And I'm gonna go ahead and look at the data. So kind of the same view here where I'm looking at my results sets. But here, if I look at my customer 12212, I now have 100 accounts. And each one of those accounts has a different value. But this isn't very fun. Let's do this from the actual application. So to do that, I simply need to use my data source name here. And I'm going to go back and hook up my virtual service to that data source. And that's quite simple. I can go into my library of test cases. I can look for my service, which is this one, Parabank DB. Currently, it's set to this Parabank database. I'm going to go ahead and set it to this Parabank mask generated and save. And then if I go into my application and I look at my accounts, as easy as pie, I have 100 accounts. We did that in about 15 minutes. And so I see this as a very viable approach to getting just the data that you want for your data requirements. And it's all through leveraging a combination of test data and service virtualization. Now, there's one last activity that we can do with our data here, and that is in the ability to find just the right data. So this is subsetting. And so, you will get to a point where you're generating data for yourself using seeds, different formulas, building just the right data that you need. And then you may want to change that data or pare down that data based on certain rules. And the cool part is that up to this point, you've actually already set those rules, and they are your constraints. Let's say that for my purposes, I just want the negative accounts. I don't need any of the positive accounts. All right, fine. I could have just generated negative accounts, but let's say this is the data that I had to work with. I can go back into my data model here, and I can say that in this data object, my constraints indicate that this number should be between 100 and 4,922. Well, I know they're not because I've generated. But my original constraints from what I recorded said that's what it was. And it's actually even telling me that. It's saying you currently have 160 accounts that are outside of your range. So what I can do is I can actually change this and say, you know what? The new data constraints that I want you to use all range from 0 to negative 5,000. And the idea here is that I'm only going to look at data. Oops, sorry, did that backwards. Negative 5,000 and 0. I'm only going to look at data between those two values. So I'll save that. And just the same as I did before, I could subset. I get a data source here called Parabank Database Mass Generated Subset. I could put it into the existing data set that I have if I want, but I'm going to preserve that just because. And now what it's going to do is it's going to carve out all of the accounts that do not comply to my data constraints. And this is quite powerful because if you have a whole bunch of rules, like for example, I only want to show accounts that exhibit a behavior where the rules follow something more complicated, it becomes quite easy. Okay. So how does service virtualization help the test data management problem? it simplifies the whole problem of test data management by carving off those applications of test data that could be simplified by creating isolated representations of the dependent components. And by creating a self-service management mechanism that allows individual testers and developers to build just the data that they want for their requirements. The data in a virtual service is much faster, scalable, easy to store, easy to archive, because you can take different snapshots of it and store it in an easy to load and reload way. And it removes the complexity of the different relationships. By linking service virtualization and your test data now with your test automation, you can use the same strategy to preload your automated test cases against your APIs or your UIs with test data. And you can synchronize that test data between your tests and your backend virtual services, making the whole thing much, much easier. All right, so what are our takeaways? We want the right keys. And so by combining service virtualization and test data management, we can get a simplified approach to the data challenge. Very simple lifecycle: capture the data, mask, make sure it's safe, use that for a model, and then on top of that model, you can then generate whatever data requirements you have, and then subset that. Don't forget that masking step. It's critically important. And then service virtualization allows us to get this type of data into environments that it might not even exist, and to have the complexity that we require to do full types of testing against our applications, and even prototype applications that don't even exist. And we can use different data sets by simply changing or swapping out dynamically the different data sources against the virtual services, so that we can satisfy each individual tester's different requirements. Okay, well, that about wraps it up. I do want to say one last thing. This test data assistant through Parasoft is available today. If you're an existing customer, contact your account representative for more information about getting started with it. If you're interested in diving a little bit deeper, I have put some blogs here, an overview of test data, as well as 2 examples of application. And for those techie people out there, a little tutorial that's available from our docs, so that you can go through actually the exact same thing that I just showed you, and really get a jump start on that. Okay, well, let's go ahead and wrap up with questions here. See, I have a couple here. So if anybody has any questions, now is a good time to throw them in to the Q&A box. First question here. Any idea on test data management in Salesforce applications? Absolutely. So we deal with Salesforce applications from an API perspective. There's the REST APIs that are Swagger documented for Salesforce. And typically, what we see organizations do is they'll record the transactions against the APIs that they're interacting with when they're building their new modules in Salesforce. They'll record those transactions and build simulations of what the Salesforce behavior that's backing, whatever their data requirements are, and then simulating from a REST or a SOAP perspective. There's no SOAP in Salesforce, but simulating from that perspective, and then doing everything that I just talked about, as well as from the database perspective. What's stopping service virtualization from replacing the service if it's virtualizing it altogether? What is stopping service virtualization from replacing the service? It is virtualizing altogether. Okay, so I think the question that you're asking is, so if the virtual service has the right behavior and the data that I need, why not just use the virtual service instead of the real service? Well, virtual services build fast, but governance and best practices around service virtualization is to use it to create a simulation to satisfy the dependencies of the application that you're working against, thus allowing you to replace the dependencies of your testing requirement. This makes it easier for you to build that without having to actually understand how that dependent service works, but it really shouldn't have the full complexity of that backend service. You could build it, but you don't need to. I don't know if that answered that question. Let me know if you have more, if you require more information on that. Will Parasoft Service Virtualization support Salesforce application? Oh, will Parasoft Service Virtualization and DAppProf support Salesforce applications? Yep. If you're testing your APIs, and you got your databases, and you're recording that. We're recording JDBC, so that's an easy way to support that. I do encourage you, for more information, to go ahead and head to the software.parasoft.com/try and reach out to us, and we can have a more in-depth conversation about that. But the short answer is yeah. Let's see what else we have. When a company has Community Edition of Virtualize, but does not contain Virtualize, so switching to CE, would we lose any ability in switching to CE version? No, it's the other way around. So CE version is the free version of Parasoft Virtualize that has the capability of virtualizing REST and SOAP services. And it's really based around getting started, easily using it in development cycles when you just need to, virtualize something really quick. The full version of Virtualize leverages the same artifacts. So whether you create them in the Community Edition or whether you create them in the full version, the Community Edition artifacts can absolutely go into the full version. And I'm using the full version today because I'm doing the JDBC and some of the test data. Can the solution handle manipulative functionality, changing the balance of an account via transfer or withdrawal in the application under test? Yes, so you're talking about stateful virtualization, absolutely. We do stateful virtualization when dealing with REST, SOAP, microservices, anything that has a message payload. We can easily link the different services together with something we call a CRUD tool that allows us to easily communicate data into the data repository, change the balance. In your case, if I transfer funds, it would change the funds, and withdrawal would reduce the funds. Yes, absolutely. Okay, is it easy to is it easy to reset the data sets to their originally created values to allow for retesting? Absolutely. We have a data import export, which also has an API associated with it. You can simply take a snapshot before, do whatever you want, use the button to stuff it right back to its original state, or there's an API to do that as well. I need to create test data that exists in Office documents, Word, PowerPoint. Are there tools to help generate the data in these types of docs, especially specific formats, table of contents, paragraphs, charts, tables, etc.? I'm not 100% sure about Word. I do know that I have some organizations that generate their flat data sets in Test Data Assistant, build a whole bunch of rows and then export that to CSV, which can be used in Excel. I think that the Word is a binary object, so not 100% sure, but contact Parasoft info to get some more information. Can TDM tool handle large data sets? We found many things like masking can take a long time. If you record millions and millions of rows with other TDM, any input on how long it would take to virtualize something that long? Also, how does it work with Hadoop Hive? So a couple of questions there. Basic answer I would say is any interface where we're communicating via JDBC to a database can be recorded. Any interface actually that's an API can be recorded, and that data can then be abstracted into the data repository. The cool thing about doing this based on recordings is you're not actually pulling millions of records out of a database. You're only recording the data that's a subset of that production database, the data that's important to you, that you invoked and that you collected as a part of your recording. So it's much smaller. And then on top of that, if you want to change that to be a large data set for performance testing, you can apply whatever business logic you want, just like I did here, and then generate a giant data object. And yeah, it does really good with that. Okay, let me do, I'm going to do one last question here. Actually, our two last questions are the same. They're asking about mainframe applications. So yes, so if you want to record against a mainframe, so something like MQ or TCP, or off of a mainframe to DB2 via JDBC, you can absolutely do that. And then the question here was, is there an option to provision and track data generated in mainframe applications? So same answer is from open system to mainframe, you can record your REST, TCP, MQ, whatever that interface is, and then to those backend databases. Okay, thanks everybody for joining today's webinar. I hope it was insightful. Thanks everybody. Goodbye.